Alright, so when we're talking about forces, we first need to go over the basics, and more specifically, the fundamentals around forces in AP Physics. So, the first thing you need to know is that there's something called, oh, that's a weird looking N, but there's something called Newton's laws, which to the average AP Physics student is quite common sense or common knowledge about what these laws are, but I'm just going to go over them step by step. So, law number one states that an object at rest stays at rest unless acted upon by an unbalanced external force. So what that means is that, say this box is not moving at all, it stays at velocity equals 0 unless it's acted upon by an external force. That's basically what it means. And similarly, a box that is moving to, say, the right at like 5 meters per second, it stays at, oh, come on, you gotta be kidding me. My pen died already? It stays at 5 meters per second unless an external force stops it from moving at that speed. So that's basically what the first law is saying. For the second law is basically stating that the force of an object is equal to its mass times acceleration. And this is basically probably the very general AP Physics formula when it comes to forces and dynamics. You're going to use this formula pretty much all the time with forces or whenever you're dealing with forces. Yeah. And then the third law is going to be talking about how for every action there's an equal and opposite reaction. So let me show you what this means. So say you have like a wall right here. This person is pushing the wall. So on one side, there's two forces of push happening here. A force of push is basically like a type of force in which something is pushing another object. Like in this example, the person is moving or pushing this wall, right? So there's two things going on here. There's a force of push from the hand to the wall, but there's also a force of push from the wall to the hand. And this is what we call a force pair. They're equal and opposite. They have the same magnitude, which is why the wall's not going to move, but they're going in completely opposite directions, and that's why the wall doesn't move. Okay, so I did say I was going to talk about the force of gravity. So the main thing you need to know about the force of gravity is its formula, which is m equals g. Now, if you're new to physics, you might be wondering what the hell is g? Well, you remember in the kinematics unit how we had acceleration due to gravity, which is equal to negative 9.8 meters per second squared. Well, g, hilariously, is literally the same thing, except it's equal to positive 9.8 meters per second squared. When it comes to forces, the acceleration due to gravity is positive. Yeah, that's just the main difference. And then the mass is just like the mass of whatever object you're measuring. So, for example, the mass of this block is like 2 kilograms, which is what it's measured in. Okay. Now let's talk about something else. Let's talk about the net forces. So what net forces basically are, um, by the way, I'm not delving too deep into the mathematical fundamentals yet, just because it's really, at this point in the AP Physics 1 curriculum, it's very crucial to understand each of the material conceptually first. Okay, so what the net force in net is basically equal to the net force, yeah? And there's two types of net forces. There's net force in the x direction, and then there's net force in the y direction. Now, if you're doing, say, net force in the y direction, then it would be like this, and it would be equal to the sum of the forces in the y direction. So that'll be the force of gravity right here, and the normal force right here. And now for a different type of force is the force of friction. My phone's buzzing. Which is probably like one of the most important force types that you're going to need to know in AP Physics. And there's two types of friction that you're going to need to know right now. Okay, so on one hand, there's static friction. What static friction basically means is friction when the object is not moving. Then there's kinetic friction, in which friction is present, but the box is still moving in the opposite direction of friction. So it's basically like, say we have 5 newtons here. That's what forces are going to be measured in, is in newtons. And then say 10 newtons here. This is an example of kinetic friction, not static. Now, this would be an example of my God, this would be an example of static friction when the force of push, which is on the right side, is equal to or less than the force of friction on the left side. The formula for the force of friction is equal to mu times the normal force. Now, if you wonder what mu is just the coefficient of friction. Whereas the net force is, as we discussed earlier, the force that opposes the force of gravity. But generally, it's also equal to the force of gravity, because when you think about it conceptually, when a box is like, it's on the ground, right? It's not moving up or down. In that situation, that's when the net force in the y direction is equal to 0 because it's not moving, which means that these two variables are equal to each other, because the net force in the y direction is equal to, oh wait, no, not force of gravity, normal force minus the force of gravity is essentially what it's equal to. Okay, now let's go over an example. Okay, so in this problem we're given a box with a weight of 50 newtons is initially at rest with a coefficient of friction of 0.25. Calculate the net acceleration on the box for the following forces of push: 0 newtons, 5 newtons, and 40 newtons. Alright, so let's diagram this. Solving these kind of problems is kind of similar to how we solve kinematic problems. Okay, so when it says weight, it's not talking about the mass, because the mass is measured in kilograms, right? This is measured in newtons. What it's talking about is the force of gravity. The force of gravity, to sum it up, is basically the weight of an object. Yeah? And there's a way to simplify. Well, actually, we don't really have to in this case. But if you want to, you would use this formula. If you have to find out its mass, you would just do f of g divided by g. I don't think we have to do this here. But let's list out our givens. So we have the force of gravity, which is 50 newtons. We have a coefficient of friction of 0.25. So we can actually figure out the force of friction because remember, there is no movement in the y direction, which means the normal force has to be equal to the force of gravity. And using the normal force, we can figure out the force of friction. And then we can solve for the following forces of push. Let's do 0 first. So let's calculate for friction all the way down here. Remember this formula, 0.25 times 50. You can put that in your calculator. Get 12.5 newtons, and that's your force of friction. And so basically here, for 0 newtons, we have 0 newtons of push, but we have 12.5 newtons of friction. Now, here's the incorrect answer. If you take it as that since the force of friction is greater than the force of push, then it's moving in the direction of the force of friction to the left, right? That's not what's happening. That is not how physics works. Basically, what the force of friction value is telling you, it's basically telling you like the minimum value that your force of push has to be greater than in order for the box to move in the direction of the force of push. Here, there is no force of push, and it's not greater than or even equal to the force of friction. So that would mean our acceleration is 0 for 0 newtons because there's just no movement going on here. For a movement to happen, the force of push would have to be greater than the force of friction. It would just have to be. Whereas if it's equal to or less than the force of friction, there's just no movement at all. So we've solved for 0. So let's put this on top. A equals 0. Now let's solve for 5 newtons. For 5 newtons of push. Now if you diagram this, we've already solved for everything else here, so we don't really need to, we just need to diagram this basically. Again. Now, you can see that again, the force of friction is greater than the force of push. That's a terrible looking symbol. So, again, the acceleration would equal 0. So there's no movement. Oh, whoops, we don't need to erase that. We're going to be diagramming this anyway. Now let's do it for 40 newtons. So 40 newtons of push, 12.5 newtons of friction. And you can finally see that the force of push, that's not a P, that's an F, is greater than the force of friction. So now it makes sense to solve for the net acceleration in the y direction. So the way you write this, remember that force is equal to mass times acceleration, right? So you'd have mass times acceleration. Oh, and in this case, you would need the mass. So let's solve for that. So 50 divided by 9.8 is about 5.1 kilograms. And it would equal the force of push minus the force of friction. And you can just do the algebra here. You divide m on both sides. This is the force of push. This is the force of friction. And then you can just plug this into your calculator. You would have to plug in 40 minus 12.5 divided by 5.1. You get your acceleration of 5.39 meters per second squared. And this is your acceleration for 40 newtons of the force of push. Okay, so in this problem, it's not as straightforward, but it's still not too hard, if I'm being honest. But it's basically saying that a 7 kilogram box initially at rest is pulled with 142 newtons to the right. So we have our mass and our force of push right then and there. The coefficient of friction is 0.22. Calculate and then acceleration. So we're solving for the same thing here, just with different givens. So we know our mass, we know our force of push, and we know our coefficient of friction. And we can calculate and we're trying to figure out our net acceleration in the x direction, obviously, because it's not going to be moving in the y direction. Force of gravity, we can just calculate for. We have m and we have g. Get 68.6 Newton. And this is also equal to our net force. To our normal force, sorry. Then, since we have our coefficient of friction and our normal force, we can already calculate for the force of friction. So we have 0.22 times 68.6 and I guess you can round it to the nearest tenth. 15.1 Newton. Okay, now we can solve for the net acceleration. So remember, and just before you do, make sure you check to see if the force of push is greater than the force of friction, which in this case it is. Much greater. So since it's greater, we know that there's acceleration in the x direction. Divide both sides by m. Let me clean this up a bit. You just plug in the numbers. 142 minus 15.1 divided by 7. So when you plug in the numbers, you end up with 18.1 meters per second squared if you round to the nearest tenth. And as much as I am concerned, that is all we have today for your introduction to forces. In the next video, we'll go over tension, which is not so easy, to say the least.